I would like to give the floor now to Professor Éva Lubloy from the Department of Building Materials and Civil Engineering. Éva is Dr. Majorosné Lubloy is a professor at the Department of Construction Materials and Technologies and the director of the Knowledge Center for Water Sciences and Disaster Prevention. Very relevant topic. She started her studies at the Faculty of Civil Engineering at the Budapest University of Technology and Economics in 1996 and graduated in Germany in 2001. He holds 2 professional engineering degrees, concrete technology and fire protection design. Her main research interests are the behavior of building materials under fire and non-destructive diagnostic methods. Éva, the floor is yours.
Thank you. Sorry. Yeah, I think fire protection is today very important topic. We have more and more fires. The causes are that we have changing in the fire laws. The changing in the fire laws is important if we see they come from electrical cars, from accumulators, and we have some problems with the new materials, for example, plastics. We should know that plastics and electrical cars have other fire behavior like other materials. We have higher fire development, and they give more energy for fire. What's happened if we have an electrical car in the garage? That is the situation. You see, here we have a reinforced steel, reinforced concrete slab, and the steel is collapsed because the electrical car is burned. I think it is very dangerous, and we should think about this, that the fire load is changed, materials are changed, and we should think more about the fire protection. Yeah, the question, it is better if you use steel? The answer is not, because steel structure collapsed from very low temperature. They collapsed by 500 degrees, and here you see the partial protection for a parking garage in an airport. Other pictures are the same. I think it is good to see the deformation of steel structure because we have very high fire loads, and it is important that the number of the electrical cars is always higher, and we should thinking about the protection, how we could protect the buildings. Yeah, what's happened with the concrete structures in fire? First, it is important we have changing of the concrete technology in the years. Requirement from the engineers are higher concrete strength. From this we have higher density, and we have smaller cross sections. And we have new concrete types. One interesting concrete type is the geopolymer from concrete. Geopolymer concrete not use cement, and they has very high fire protection, but at the moment we have problems with the production. From this, we can have in concrete structure problems in fire. What happened with concrete structures? Yeah, I think it is not dangerous, swelling of the corners. It's not good, but it is not really dangerous because we have not damaging the load-bearing structures. But in this case, if you have hollow core slabs, then the undergird can collapse, and we can have some problems with hollow core slabs, with hollow elements are really dangerous in fire because we have other heat effect inside these holes. Yeah, you can see that is a reinforced build structure. We have relative large deflections and relative big amount of spalling, but they don't collapse. That this picture was made for 15 years about. In this time, we haven't not good concrete. We have not high strength concrete. We have not high density concrete, and in this time, it was not dangerous if we use concrete. What's happened with reinforced concrete in fire? First of all, we have hydrated cement on this decomposed in function of temperature. We have aggregate. The bond of aggregate to cement stone decomposed too. We have fibers. The fibers could help in case of fire. I explain it later. And we have bond between reinforcement to concrete on the decomposed too. Why could have fibers? We have other problems in fire, the spalling of the concrete cover. The spalling of concrete cover comes from escape from water in fire. Water boil in fire and will escape in form from gas. But if we have not pores, we have higher density, higher concrete strength, then we have spalling of concrete cover. If you use plastic fibers, then you can have, after the melting of plastic, some extra holes and water can escape on concrete. I will not explain this picture because it is more chemie, but it is important to know that hardened cement paste is the most important part from concrete. And we have two main components. The first is the calcium hydroxide, and they decompose after 500 degrees. Okay, and we have calcium silicate hydrates, and they decompose after 700 degrees. Calcium hydroxide is responsibility for the bond characteristic, from the bond of aggregate, from the bond of reinforcement. And calcium silicate hydrates give the strength of the concrete. They are important things because by choosing of good cement type or good supplementary material, we can reduce the amount of calcium hydroxide and we can make better concrete. Yeah, I think it is always important working with the industry. We have made a lot of lab experiments. We say that concrete composition is perfect, but it is the question, it is good for the production of structural element. Yeah, we have made testing of structural elements too. I will present there two interesting cases. The first was for 30 years, 20 years about. It was a very interesting element because we have a small girder, 6 centimeter is nothing, and relative high, above 1 meter. And these elements are really dangerous in case of fire because the heating of the girder is rapid. Yeah, it is possible to calculate. The answer is not. Because if you use the 500 isotherm method, then we see that we have no girder. In this case, we have nothing to transfer the shear forces. It is true. Not, we should make fire tests. Fire tests are really big element tests. The first was the situation after 12 minutes. I think it is good to see that the spalling of the concrete cover happened on the girder collapsed. Okay, the question, how we make good concrete composition, how we made good girders. The requirement was from the industry 60 minutes, and we made 71 minutes fire resistance, only changing the concrete composition. Nothing is changed in the structure, in the reinforcement, on the geometry, only the concrete composition. Yeah, the conclusion. We have a relationship between the microstructure and structural element. For that is very important the research in the university, that we know what's happened in small samples, because in big samples, fire experiments are very, very heavy to make. What have we made? First, the first experiment was made with supplementary material limestone without polypropylene fibers. Second experiment was made with limestone and with 1 kilo polypropylene fiber per cubic meter. I think in this case it is to see that we have over 50 minutes fire resistance. It is good to 12 minutes, but requirement was 60 minutes. What could you make? We changed the supplementary material. We changed the supplementary material to slag, and slag is not sensitive to fire, and we can have more than 60-minute fire resistance. Yeah, other exemplar. It was for about 10 years or 5 years. That is a wall panel elements. Wall panels are interesting because they have high fire requirement. They have isolations and load-bearing capacity, and they should they should protect it from flame effect too. We have tested this also in fire. Yeah, the first was only 90 minutes. The requirement was higher from this. Changing the concrete technology, we used polypropylene fibers on slag too. We have made 120 minutes, and we have flame effect by the slabs. And it was problem that if the flame come out, then collapse the structure. And we work on the connection, and after working the connection, we couldn't have more than 3 hours fire resistance. I think it is in the industry very important that we have walls that could protected the industry parts. Yeah, what happened with the elements? First, in the first first mix, we have spalling of concrete core. I think it is to see that the reinforcement deformed. In the second, after changing the concrete composition, we have smaller amount of the spalling of the concrete core. Yeah. What happens if we have steel structures? In case of steel structures, the direction is that we use always smaller cross sections. Yeah, if we use slender structures, smaller cross sections, then we have problems. We have other statical problem, for example, buckling, and we should make the measurements other. And thin cross section could heat it relatively rapid, and we have problems. Yeah, how we can make testing of the structures? That is really so. We put in a furnace, we loaded, and we measured the the deflection, and the temperature. Yeah, if we see, then this cross-section could rapid overheating, and they are very sensitive to fire. We have made more than 20 fire tests, and we have developed from this a calculation software special for trapezoid sheets. And we have calculated all problems, the plate deformation, the deflection speed, and we could calculate the connection too. And the most sensitive points, according to calculations, are the connections. And that was brand new for the industry, that we have more, we should have more attention for the connections. And thank you for your attention.